All right. So we are going to be going over the two worksheets that we're dealing with. First one is just straight up momentum. And all right, it's got a little bit of notages here, which is more difficult to stop. A tractor trailer moving down the highway at 35 meters per second, or a small two-seater sports car traveling at the same speed. Well, I'm assuming that the car is less than the truck, so it's going to have less momentum. Therefore, it's going to be a little bit easier to stop. You can find momentum using the equation. Momentum, which is P, mass of the object, M, and velocity, V. So we can throw that into our magic little triangle. P is equal to M times V. So there's going to be parts where you're going to have to solve for mass. If I cover that up, mass is P, or momentum, divided by V. If I'm asked to solve for velocity, I would do P over M, so momentum divided by mass. And if I'm asked to solve for P, if they're next to each other, you multiply. The unit for momentum is kg times meters per second. The unit for velocity, meters per second. The unit for mass, kg. We need everybody in those units. All right, we definitely want everyone in those units. All right, so the first one, number one, truck has a mass of 2,000 kilograms. What is the momentum? So they want P. Covering up P in the triangle is M times V, mass times velocity. So mv, which would be M of 2,000, times velocity of 35. Multiplying those out, we should kick out an answer here of 70,000. And since we're dealing with momentum, kg times meters per second. All right, pretty simple. Should be. The next one is the same thing. It's just the mass is cut in half. So if I decrease the mass by a factor of 2, the momentum should be decreased by a factor of 2. The answer is going to be 35,000. You can show the work for that. But I do want to run through a couple different types of problems. So in number 3, you have an 8-kilogram bowling ball moving in a straight line towards you. If its momentum is 16 kg meters per second, how fast is it traveling? V. So again, if you're not familiar with the triangle, if I cover up V, it's going to be P divided by M, P over M. V is P over M. So you then throw in your numbers. 16 over 8, and that is going to give us 2, and the unit for velocity, you're 2 meters per second. Beach ball. If you have a beach ball, excuse me, rolling a straight line towards you at a speed of 0.5 meters per second. So I have V, 0.5. And I have a momentum of 0.25 kilogram meters per second. What is the mass? So again, if I go to the triangle, if I cover up M, M is equal to P divided by V. So M is equal to P over V. If P was 0.25 and velocity was 0.5, you are going to get a mass of 0.5 kilograms. Okay, so Number 5. If we start here at number 5, we have mass 4,000 kilograms. It's moving in a straight line at a speed of 10 meters per second. What is the momentum? P is equal to m times v. So if I'm doing 4,000 times 10, I'm going to get 40,000 kilogram times meters per second. Now 6 says a 1,400 kilogram car is also traveling in a straight line. Its momentum is equal to that of the truck in the previous problem. So what is the velocity of the car? So they're basically saying, okay, your answer from 5, that's the momentum. So 40,000 kilogram meters per second. They're saying now the mass, it's a car, is, all right, definitely less, 1,400 kilograms. What is the velocity that this thing is moving? Wait a minute. Can a truck and a car have the same amount of momentum? Even if the truck is heavier? How? Yeah, it needs to be moving faster. So do you think, right off the rip, your answer for the velocity should be more or less than 10 meters per second? More. All right, so you definitely know it's got to be more. If it comes out less, we did something wrong happened. Velocity is momentum over mass. 40,000 over 1,400. This comes out to be approximately 28.57 meters per second. So yeah, definitely pretty solid there. So this one, guys, they're asking which would take more force to stop, all right? So to change its momentum down to 0. Would it be an 8 kilogram ball rolling in a straight line at a speed of 0.2 meters per second, or a 4 kilogram ball rolling in the same path at a speed of 1 meters per second? The second one? Why the second one?
What was the question? Oh, it would be the first one.
The first one is heavier.
Just because it's heavier does not mean it has greater momentum, though. So if you do the right mass times velocity for the first one, mass is 8, velocity was 0.2. So this comes out to be 1.6 kilogram meters per second. The other one had a mass of 4 kilograms, but a velocity of 1, which comes out to be 4 kilogram meters per second. So because if we're bringing them both down to a stop and 10 seconds, yeah, I need more force in order to bring this to a stop. Does that make sense? Yeah. So it's the second one that is going to require more force in order to cause it to stop. All right, now 8, guys, you should be able to do. 11 easily you should be able to do. 9, 10 are pretty simplistical, but we're just going to roll through them really quickly. You have a 0.14 kilogram ball.
Oh, we're doing 9. I thought we were doing 10.
9, 10 combo, sort of. So they tie into one another. So the 14 kilogram ball thrown at a velocity of 30 meters per second. What is the momentum of this baseball? Mass times velocity. Mass is 0.14. Velocity here is 30. You're going to get a momentum here of 4.2. And the unit for momentum? kg times meters per second. Okay, so this is the momentum that this ball has. Now it says another pitcher throws the same baseball in a straight line, and its momentum is 2.1 kg. So right now, the only number in the problem that I see is this 2.1 kg meters per second. They want velocity, but I don't know what m is. Well, if they're talking about the same baseball, then it would have the same mass. All right, so the mass of that would be the mass of the ball from the previous problem. Velocity is p over m, in which case you are doing 2.1 over 0.14, and you are kicking out a velocity here of 15 meters per second. So you guys should definitely be able to do 8, 11, and the one on the front that we did not do. So the next one I'm going to pass out, guys, has to deal with energy. Not energy. It has to do with momentum and impulse.
Say if it breaks in the first hole, would be your grade?
Fail. Double fail if your phone case breaks on the first shot. From 30 centimeters, yes. It'd be bad. Yeah, because honestly, you might be able to just drop the tile from that height and be okay.
So you just got a bad top.
Maybe. All right. So we have our next assignment. Our next list of problems here are on impulse and momentum. All right, so please make sure, everyone, we are on this worksheet now. We are on this assignment now. The one before that, little easy. This one, I wouldn't say it's necessarily like much harder. It's just an extra step. So we need a couple things. This equation is the impulse momentum theory. All right, impulse momentum theorem. All right, so in which case you have the change in momentum is equal to the impulse. That's what this is, and it kind of actually says it underneath. Starred, change in momentum, which is in kilogram meters per second, is equal to an impulse, the impulse acting on it, which is in newtons times seconds. You can, if you're looking for just an impulse and you have the force and time, you can just multiply those two together to find I, and the unit will be in newton seconds. So, number one, a force of 6 newtons acts on a 1.5 kilogram mass for 5 seconds. Find the impulse which acts on it. Okay, if they just want impulse by itself, impulse is equal to I is equal to force times time. Force is what unit? The newton. And time, 5 seconds. What is 6 times 5, y'all? Hell yeah. And the unit will be newton times seconds. Okay. They want to know what is the change in momentum. They want m times the change in velocity. Well, literally I wrote it in parentheses. Change in momentum is equal to the impulse, just different units. So, same number. Different units. So instead of 30 newton seconds, the unit for momentum is, yes, kilograms times meters per second. Now they want you to therefore calculate the change in velocity of the object. Change in velocity, that's what delta V is. That's all that means. So the easiest way to do this problem is put, all the guys with their units underneath the right variable. So 6N newtons, what would that go under? MV, F, or T? F. So I'm going to drop my equal sign real quick. So newtons is force, so I'm going to put that under F. 6. Next one is kg. What is that going to go under? MV or T? M. All right. Kilograms is mass, so 1.5 will go under M. They want us to solve for this, so we're going to leave it there. And then they said 5 seconds. So 5 seconds is our T. So guys, if I really just want delta V by itself, all I got to do is to make sure I divide both sides by 1.5. So basically, this is goodbye, and so this is going to equal 6 times 5, which is 30, divided by 1.5. And that comes out to give us 20. And the unit for velocity, meters per second. Now, the little triangle, again, guys, just means the change in speed. So this is basically telling me I've increased my speed by 20. We've increased our speed by 20. So does that, now there may be a question, would be like, okay, well, if you were moving, let's say, at 5 meters per second, and then a 6 Newton force acted on your mass for this minute's time, what is your new velocity? Well, if I was moving at 5 and I changed my velocity by 20, what would my new velocity need to be? If I was at 5, and now that force and time, so basically imagine you're riding a little bike, all right, and you're moving at 5 meters per second, let's say. Someone comes from behind, pushes on you with 6 newtons of force for 5 seconds, and now you have increased your speed by 20 meters per second. What would your new speed be, or your final speed? You increased by 20.
Yeah.
If you originally started, let's just say you started at 5, all right, someone came along, pushed you, and now they've caused an impulse, all right, momentum change here of 20 meters per second. So now, well, if you're moving at 5, you increase your speed by 20. Thank you. So you may sometimes see a problem like that, all right, where they actually give you like an initial velocity. They said, find the change in momentum. All right, you did, what does that speed come out to be, that change in speed? You find it, and then you add the two together. All right, there would be 2 problems like that actually on the back of this. Okay, this one should be pretty simple. Again, my advice would be to put the variables underneath the letters. So what is the unit for, or if we're looking at number 2, okay, 8. N is what unit? Is it, it's the Newton. Is that for mass? Is that for velocity, force, or time? Force. So I'm going to put 8 under F. Bring my equal sign down. What else do I have? I have 2 kilograms. All right, kg is mass. And in order to change its velocity by 5 meters per second. So V, meters per second, is the unit for velocity. And they want to know how many seconds. So we don't know what T is. So guys, if I wanted T by itself, I got to divide both sides by what?
8.
Mm-hmm.
So
2 times 5 is 10, and then divide that by 8, comes out to be 1.25 seconds. So not these ones, not very difficult. But let me ask you something. Can you get a negative velocity?
Probably.
Yeah. What is a negative velocity usually going to mean? That it's either slowing down or going backwards, right? Okay, so let's say this. Let's look at number 5. Let's skip 3 and 4. All right, because they're just done like these two right here. So if we're looking at 5, you have a 10 kilogram object traveling with a certain velocity. All right, we don't know what that is just yet. Let's say this thing is moving to the right. Now, if it is acted upon by a negative 5 Newton force, if we take things as positive meaning right and negative meaning left, so basically if the object is moving to the right, we have a force acting to the left, and that is going to probably wind up causing it to slow down. So 10 kilograms, that's our M. We don't know what V is or change in velocity. Force, negative 5, and time, 4 seconds. So guys, how do I get delta V by itself? Yeah, divide both sides by 10. Negative 5 times 4 is negative 20. So negative 20 divided by 10 is going to be a negative 2. So let me ask this. This negative 2 is basically telling me my object slowed down. So if a second part of this was like, hey, if I was moving at 10 meters per second, what is my new velocity? If I was moving at 10 and I have a change in velocity of negative 2, what would my new speed be? What would my new velocity be?
8.
Very good. 8. All right, so 10 plus my change, which is a negative 2. Now, again, that's how you would do a problem if they asked you something like that. They're like, oh, yeah, this thing was moving at this speed, but we need to figure out what the change in speed was. Well, if we slowed down by 2 and we were moving at, let's say, 10, you'd be now chilling and moving at 8. All right, you can figure out what 6 is because of time. All right, again, you can have a negative force or a negative velocity. You can't have negative time or a negative mass. So let's take a flipper. All right, golf ball has a mass of 0.1 kg. 7, you're just going to do mass times velocity for each, and they're going to ask are they the same? All right, you have 2 kilograms, a 2 kilogram cart moving at 30 meters per second to the north, and you have a 1.5 kilogram cart moving at 40 meters per second to the south. Do they have the same momentum? All right, so you multiply them out. Do they have the same magnitude? Number 8, you have the mass of a golf ball. Now, after the impact, it says that it moves with 50 velocity, right? 50 meters per second worth of new speed. If the club and the ball are only in contact for 0.005 seconds, what is the force or average force acting on it? So the time is 0.005. Sweeney, how do I find F?
Divide by 0.005.
Good. Divide both sides by 0.005. Okay, that kind of gets rid of this like, goodbye. So in your calculators, you would just do 0.1 times 50, and then divide that by 0.005, and F will come out to be 1,000, and the unit for force is the Newton. So in this case here, 9, a billiard ball with a mass of 0.2 kilograms is thrown against a steel plate, and it rebounds as shown. So see how it's moving to the left. It has a negative 20 meters per second worth of velocity. Hits the wall, bounces back with 18 meters per second worth of velocity to the right. They want to know what it was the change in momentum of this billiard ball. So I've rearranged the equation for you guys very simplistically. You're going to type in, all right, what was my mass? 0.2 kilograms. My final velocity is 18 minus my initial velocity, which was negative 20. So 18 minus a negative 20 becomes positive 38. Positive 38 times 0.2. And you'll get 7.6 kilogram meters per second of change of velocity, or sorry, change in momentum. Okay, now 10 and 11 are basically done the same way. So we'll do which one do you guys want to do, 10 or 11? All right, we'll do 10. We'll do 10. So a 3 kilogram object initially traveling with a velocity of 4 meters per second. All right. So it's initially traveling at this speed. What is this object's momentum then? Well, m kilograms is m, so I'm putting the 3 under the m. V has units of meters per second, so I'm putting the 4 under v. And so momentum is equal to, what's 3 times 4? Yep. And the unit, kilogram meters per second. Okay. So this is the initial momentum of the object. Why is this our initial momentum? Well, we're just told that we have a 3 kilogram object that's originally or initially traveling at 4 meters per second. Now they're going to say, okay, if a 5 Newton force comes in and acts to the right, which we're saying is positive, for 1.8 seconds, what's the new momentum? So a change in momentum, remember, is equal to the impulse. So a change in momentum is equal to force times time. So literally, you're going to do newtons is 5, and Newton is the unit for force, so 5 goes under F. Time, all right, has the unit for seconds, so this 1.8 is going to go under T. So the change in momentum comes out to be 5 times 1.8 comes out to be 9 kilogram meters per second. So I've changed my momentum. I've increased my momentum by 9. So what is the new total momentum? Well, I wrote, find the change in momentum and add it to your answer from part A. My answer to part A was 12. And then our change, all right, so we've increased our momentum by 9. And so, yes, we will have 21. kilogram meters per second as the new momentum. And again, how did our momentum increase? It increased due to the impulse. So basically, imagine someone riding a little bicycle. I don't know how to draw a bicycle. This is like the handlebars. Then there's this thingy, the seat, and little pedals. Best I can do. All right. So as this, we're assuming this thing is moving to the right because our velocity, all right, or momentum is positive. So it's moving to the right. If a force comes on, all right, so basically imagine someone was behind you and then now they're running behind you and pushing 5 newtons worth of force on you for 1.8 seconds. Do you think your speed's going to increase? Yeah, and since that happened, your momentum increased, assuming there's no loss of anything due to friction. So 11, guys, you're going to do it the same way. All right, 11, you're going to do the same way. So the final answer for 11 should come out to be 12. So please make sure you guys, I want you to do that right now. All right, and I would like you guys to make sure that you are able to get this, and then you guys may pack it up.